We're continuing anti-differentiation today, and the only difference between the problems that we did yesterday and the problems that we have today, we're going to do some problems where we're given some initial conditions so that we can find out what that constant is. And this is even more like differential equations, the whole class, if you end up taking that class. You're not only going to find the antiderivative, but you're going to be given some information to allow you to find that constant. So instead of getting a whole family of antiderivatives, you get one specific antiderivative that meets whatever requirements are given. For example, number 40 gives us a second derivative of x is sine x. And then we're given two other pieces of information. F prime of 0 is 1, and f of 0 is 6. So the three things we know are the second derivative of the function that we're looking for. We have the value of the first derivative when x is 0, and we have the value of the original function when x is 0. We're supposed to find f of x that meets all three of those criteria. Well, if the second derivative is sine x, how would you find the first derivative? You may not have all the words in your head yet, but it's either anti-differentiate or integrate. Those two things mean the same thing. So we're going to anti-differentiate. We're going to use the integral sign to find the antiderivative of sine x with respect to x. And what is the antiderivative of sine x? Is it cosine or negative cosine? Just be real careful. Negative cosine. If you thought it was just positive cosine, and then you checked your answer by differentiating, the derivative of cosine would be negative sine, and that's not what you wanted right here. So make sure you say the antiderivative is negative cosine x plus some constant. Now, because we know the value of the derivative when x equals 0, we can let x be 0, set the derivative equal to 1, and solve for that constant. And then we have, instead of a whole family of antiderivatives, we have a specific antiderivative. So I'm going to try to put some words in here so you can tell what I was thinking when you look back at your notes. Since f prime of 0 is 1, that means if I put 0 in the place of x and set the derivative equal to 1, I can find the value of that constant. What's negative cosine of 0? Cosine of 0, the x coordinate at 0 radians is 1, and so negative cosine of 0 would be negative 1, and so what is that constant? Yeah, the constant's 2. Now for our first derivative, rather than having this general antiderivative with any constant, we know what that constant is, and we can say now we know the first derivative is negative cosine x plus 2. That's what the first derivative is, but we want what the original function is. So if we have the first derivative, how can we find the original function? Anti-differentiate or integrate negative cosine x plus 2 with respect to x. And what is the antiderivative of negative cosine x? If you're not sure, just put down what you think it is and then check your answer. The derivative of sine x isn't negative cosine x, so So when I anti-differentiate negative cosine x, I'd have to get negative sine x. And what's the antiderivative of 2? 2x plus a constant for that whole family of antiderivatives. And then because I'm given the value of the function, when x is 0, the function value is 6, I can do the same thing to find the constant of the function, just like I did to find the constant in the first derivative. That's f of 0 equals 6. That means if I put 0 in the place of x, both x's, I can solve for that constant. What's sine of 0? 0, and 2 times 0 is 0, so what's that constant? Yeah. And so the function that I'm looking for is negative sine x plus 2x plus 6. Now I have a very specific function, not just a function with a couple of, I don't know what the constants are, but here we go. And we can check and make sure that this function does meet all of the requirements that we were given. Would the second derivative be sine x, plain old sine x? And that's all? The first derivative would be what? Negative cosine x plus 2, which is what we got right here. And then the original, excuse me, not the original, but the second derivative would be sine x. And then we can check to make sure that if we put 0 into the first derivative, we get 1. If we put 0 into the original function, we get 6. We've met all 3 of those conditions, and I love things on the test that I can check. All right, not bad, right? I'm wondering, I think I'm not even going to do number 42. I had it circled, but I'd rather move on to the word problems. 42 is basically just like 40 in that you're given a second derivative. So you're going to have to integrate once to find the first derivative. You're going to have to use this information to find the constant in the first derivative. You integrate again to find the original function and use this information to find the constant in the original function. That was a Miles-like move, Major. Pens just go flying out of my hand all the time. All right, yeah, let's skip 42 and go on to a word problem. Actually, I'm going to make up something for you. Copy this down. Tell me what you know about the position function, the velocity function, and the acceleration function. How are they related?
Velocity is the first derivative of the position.
All right, that's said like a math teacher. What else?
Acceleration is the second derivative.
All right, perfect. Acceleration is the second derivative of the position function. It's the first derivative of the velocity function. So actually, we're being given a second derivative. Acceleration is constant. If you neglect air resistance, and every problem in a math book is some simplified version of real life. In real life, you wouldn't be able to neglect air resistance. But for our purposes, we can. So what we're given is that the acceleration function is just -32, and that's feet per second squared. If we're given the acceleration function, how could we get the velocity function?
By integrating.
Just anti-differentiate the acceleration function. The velocity function would be the antiderivative of -32. Our independent variable is t. So we want to find the indefinite interval of -32 dt. And what is the antiderivative of -32? -32t. plus some constant, and that constant is my initial velocity. It's the velocity with which the object was thrown or dropped. If the object was dropped, the initial velocity is just 0, but if it was thrown with some force, then let's say the initial velocity is phi sub 0, because that's the symbol that we were told to use. All right, if we have the velocity function, how could we get the position function? Anti-differentiate again. So the position function would be the antiderivative of -32t plus the initial velocity with respect to t. And what's the antiderivative of -32t? Oh my word. -16t squared plus what? The antiderivative of a constant. That initial velocity is a constant, so its antiderivative would be the constant times t plus some constant on the end. What does that constant on the end represent? Initial height, and what are we using to represent initial height? Holy cow. There's the position function that we've been using since about the 8th grade or the 9th grade. You like that, Alan? Pretty darn cool. That's where it comes from. The acceleration is a constant. So if you anti-differentiate, you get the velocity function. If you anti-differentiate that, you get the position function. And then we use that position function to answer questions like, when will the object hit the ground? What's the maximum height of the object? How long does it take for the function to hit the ground? That's the same thing as when. Yeah, that's the same thing as when does it hit the ground. But we can use that position function to find a lot of different things. As long as you're talking about gravity on Earth and neglecting air resistance, that acceleration is going to be -32 when your distance is measured in feet and your time is measured in seconds. Or if your distance is measured in meters, anybody remember what that constant is if the distance is measured in meters? -9.8 meters per second squared. Just to keep you from simply memorizing that, some of the problems, I think there's a problem that has something about lunar gravity. Lunar gravity, you'd start with a different constant here. But the process would be the same for finding the position function of an object either thrown or dropped on the moon. I got the bad sniffles this morning. How are we doing? Let's try 56. (56) 56, 7, and 8 say use the acceleration is negative 9.8 meters per second as the acceleration due to gravity, neglecting air resistance. And 56 says a baseball is thrown upward from a height of 2 meters with an initial velocity of 10 meters per second. Determine its maximum height. All we're given is the acceleration function. A of t is negative 9.8. And the other thing we're given is the initial velocity is 10 meters per second. We could say that's the velocity. We could use v sub 0. Oops, sorry about that. We could use v sub 0. That's also v of 0, or what we get when we put 0 into the velocity function. If we put 0 into the velocity function, then we're supposed to get 10 meters per second. So that's what I'm given. The question I want is determine the maximum height. If I want to know the maximum height, let me just write that down. I want to find the maximum height. What functions am I going to have to know? Just talk me through the process of finding maximum height. Well, I have the acceleration function. I would have to find the velocity function, and also I'd have to find the position function, because that maximum height is a position. So to find the velocity function, I would anti-differentiate the acceleration function with respect to time. And so what is that velocity function? Negative 9.8 t plus the initial velocity, which I know to be 10. Now I could have put plus a constant, but if I put plus a constant, then when I let t be 0 and set the whole thing equal to 10, then I would find out real quickly that that constant is 10. So I just didn't go through that step. That's the velocity function, and then the position function would be what? And, ooh, I love how you said that. Antiderivative of the velocity function. And the antiderivative of the velocity function would be negative 4.9 t squared plus what? Plus 10t plus, what's the constant on the end of the velocity or position function? Initial height. Were we given anything about the initial height? Ooh, it's thrown upwards from a height of 2 meters. I didn't even write that down up here. I didn't notice that I was given that. S of 0, or the position function when S of 0 is 2 meters. So That's my S of 0 on the end. Now, if I have a position function, how do I find the maximum height? The big thing on tonight's word problems, and this is huge, you have to think in words. You can't just think in T's and S's and B's and A's. You have to think, what is it that I would have to know in order to find out how high this ball goes?
Numbers for the first derivative, and then plug that number into the position.
I like how you were thinking about that. I thought about it differently. But you said the critical numbers of the first derivative, that's our possible relative extrema. And so we're looking for where the ball stops going up, 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 and starts coming down. So critical points of the first derivative, perfect way to think about that. I was thinking of it, different words, but same thing. When the ball's going up, 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 and it reaches its maximum height, therefore a split second, what's the velocity? 0. And that's the same thing as saying critical points of the first derivative. It's what makes the velocity 0. So that's what I'm thinking. But it would be equivalent to what Major thought, because Major said find the critical point of the first derivative. That's the same thing as find what makes the velocity equal 0. So negative 9.8 t plus 10 equals 0. And so that happens when t is 10 divided by 9.8. Darn close to 1 second. Have I answered the question yet? I have only answered when the ball reaches max height. I didn't answer what the max height actually is. So Major, give me one more hint, and then I'll pick on somebody else on the next one. After I find the time that it takes for the object to reach the max height, how do I find what the max height is? Plug that time into the position function. I want the position, so I plug this approximately 1 into the position function. Now I'm not going to round that. The max height at t is 10 divided by 9.8 is whatever I get when I plug 10 divided by 9.8 into the position function. Negative 4.9 times 10 over 9.8 squared plus 10 times 10 over 9.8 plus 2. Put that time in place of both of those t's in the original, or in the position function. Somebody double check me on that, but I got the max height is approximately 7.1. Anybody second that? Anybody had time to punch it yet? What would the units on that 7.1 be? Yep. My acceleration was given to me in meters per second squared, so that distance is measured in meters. Yes, sir. I'm sorry.
7.1 is good.
Oh, okay, 7.1. Gotcha. Good. All right. That one wasn't bad. There are a couple of worse ones that I'd kind of like to save till last. Let's do 64 and then we'll backtrack. 64 is not bad. Excuse me. A particle initially at rest, what is that giving me, that initially at rest? Initial velocity is 0, moves along the x-axis such that its acceleration at any time greater than 0 is given by a of t equals cosine t. So this particle isn't accelerating at some constant rate, it's accelerating at a rate given by cosine t. And at time 0, its position is x equals 3. Help me get everything that I'm given written down correctly. Tell me one thing that I'm given.
Position function.
All right. I'm not given the position function.
Acceleration function.
I'm given the acceleration function. A of t is cosine t. And then what? At t equals 0, x equals 3. Is that its acceleration, its velocity, or its position? Its position. So I'm going to say s of 0 equals 3. And the initial velocity is what? V of 0 equals 0. This is initial velocity, and this is initial position. The A part just says find the velocity and position functions for the particle. So how do we find the velocity function? Anti-differentiate the acceleration function with respect to t. And what is the velocity function? The antiderivative of cosine, is it positive sine or negative sine? It is positive because the derivative of positive sine is positive cosine, and then plus a constant. And yeah, if I know that s of 0 is 3, that means if I put 0 in place of t, I get that constant is 3, sine of 0 is 0, and
Initial velocity position.
oh, I put the initial position in the velocity function. That's not good. If I put 0 into the velocity function, I'm supposed to get 0 for the velocity. So since sine of 0 is 0, that constant is just 0. And my velocity function is just sine of t. And then what about the position function? How would I find it? Anti-differentiate the velocity function with respect to t. And what is the antiderivative of sine t? If you thought it was just cosine t, write it down and think about it. The derivative of cosine isn't sine. The derivative of negative cosine is sine. And now we can find that constant because we know the initial position is 3. Be careful with that. Don't assume that that's automatically what c is. Go ahead and say, if I put 0 in place of t, in the position function. That whole thing is supposed to equal 3. Does that mean the constant is 3? No, negative cosine of 0 is -1. So what's that constant? Yeah, that constant's 4. So my position function is actually negative cosine t plus 4. The A part asked me to find the velocity function and the position function. I have both of those. And the B part asked me to find the value for which the particle is at rest. Well, we know one time the particle's at rest. What's that one time? At time 0, because the particle was initially at rest. How will we find where the particle is at rest again? I just can't hear you. My ears are completely stopped up. That's what at rest means. So find when the particle is at rest means find t when the velocity is 0. You put 0 in place of velocity right here, not just in place of t, because we're not talking about time 0, we're talking about the velocity is 0, and we're solving sine t equals 0. For what angles does sine equal 0? All the whole pies? How do we write all the whole pies? Because there's no indication that this particle is stopping anytime soon. It starts at 0, so we don't want any negative angles, but it starts at time 0, and then how do we write and all the whole pies after that? Pi n, or I don't know, the calculus book uses k for that constant, but I'm used to, in pre-calculus, just writing it pi times any integer n. So the particle is going to be at rest at approximately 3.14 seconds, and approximately 6.28 seconds, and then approximately 9.52 seconds. Every pi seconds, the particle's at rest for just a split second. All right, any questions? Let's back up to one that's a little bit harder again. I have 2 more if we have time for it. With what initial velocity must an object be thrown upward from ground level to reach the top of the Washington Monument, which is approximately 550 feet? What are we trying to find? Initial velocity, so v sub 0 is what we're trying to find. All right, tell me what we're given. The acceleration function, it says exercises 53 to 55 use the acceleration of negative 32 feet per second. So we do have A of t is negative 32. What else do we have? The ball's being thrown from ground level. That means S of 0 is 0. What else could I write down from the problem? What's that? 550. That's the maximum acceleration, maximum velocity, or maximum height. That's the maximum height. Max height is 550 feet. And what do we know happens at the maximum height? The velocity is 0. All right, I think that's all we know. Talk to me. If I have the acceleration function, I can find the velocity function. The velocity function would be the acceleration function, antiderivative of the acceleration function with respect to t. So velocity function would be negative 32t plus some initial velocity. That's the thing we're looking for. We don't know what it is. All right, keep talking to me. Will give me the position function. All right. Actually, I want to write down one thing before that, just to keep my stuff organized. I'm going to have to find where that velocity is 0. And so I could set that equal to 0, but the best I could do is solve it for t, and t still going to have v sub 0 in it. I don't know what v sub 0 is. So I can find the time at max height but I'm not going to get a number for it. I'm just going to get an expression. It's when the velocity is 0, because that's what you told me happens at max height. T would be the initial velocity divided by 32. All right, now I'm going to take your suggestion, Glenn, and say, well, I have a velocity function, so I can find the position function by anti-differentiating that velocity function. It still has v sub 0 in it because I don't know what it is. That's what I'm trying to find. So what's the position function? And what is that constant in this case? Since it's being thrown upward from ground level, we know that that's 0. And so my position function is just negative 16t squared plus v sub 0 t. Now what? And that's ugly that I don't have a number to plug in for t, but I do have an expression that I can plug in for t. Very good. At max height, because I like using words, at max height, t equals v sub 0 over 32, and s equals the height of the Washington Monument. We put 550 in place of position, and v sub 0 over 32 in place of both of the t's. Let me just double check that. Actually, nope. I need to put it in place. I need to put that into the velocity function. The velocity function was negative. No, that's right. I'm putting that into the position function because the position is 550, not the velocity. So this is right. Negative 16 v sub 0 squared plus v sub 0 times t. We got rid of all the variables except for v sub 0, and that's what we're solving for. So I think we should be able to solve that. How ugly is it? How do you solve that for v sub 0? You could factor out a v sub 0. Actually, let me take one step before that, just in case somebody needs middle steps. I could write that right-hand side as negative 16 over, not 32, but 32 squared, because I'd have to square that whole fraction, times v sub 0 squared, plus 1 over 32 times, that would give me v sub 0 squared. So actually I could combine like terms. I got a common denominator. I'd have to multiply this by 32 over 32 to get a common denominator, and negative 16 plus 32 is positive 16 over 32 squared times the initial velocity squared. All I did was get a common denominator so I can combine those like terms. And then I could multiply both sides by 32 squared to clear out the fractions and divide by 16. That's what the initial velocity squared is. And so the initial velocity would be the square root of that. I could say the square root of 32 squared is just 32. Square root of 16 is just 4. 16 over 4 is just 4. I need to double check that. 32 over 4 is not 4. 32 over 4 is 8. Yeah, that should be it. I got about 187.6. What's the units on that? That's velocity, so it's feet per second. The problem was just a little bit harder than the others because the others we could find a number for t. We could find ball reaches max height in 2 seconds, so let t be 2. Here we couldn't find a number for t at max height, but we could find an expression for it, and then we could plug that expression in the place of t in the position function. But to do that, I have to use words all the way through. Some of you may just be able to look at it and go, well, if I do this and this and this, boom, there's the answer. And if you can do that and you get the right answer, I'm tickled for you. That's awesome. I can't. I have to think through it. I need the time when it reaches max height, and then I need the position at that time, and I need the position at that time to be 550. And then that's the equation I solved. All right, we may not have time to finish this last one, but I want to set it up. Number 68. Where is it? Right there. 68 says, assume that a fully loaded plane starting from rest has a constant acceleration while moving down a runway. The plane requires 0.7 miles of runway and a speed of 160 miles per hour in order to lift off. What's the plane's acceleration? All we know about acceleration is that it's a constant. We'll let it be K. K for constant. That's all I know so far. What are you thinking? The plane starts from rest. So initial velocity is 0. What else do you know? All right, the position is 0.7 when time is what, or when what happens. I'm not sure. Other than you're right, that's a position. I'm not sure what else to write about it. You're absolutely right. It is starting at, yeah. It is starting at some 0.0. I'm still working on writing what Sam gave me. Sam says some position is 0.7. What position is 0.7? And what's happening at that moment? That's liftoff. So again, let me use some words here. At liftoff, Sam's saying the position is 0.7 because it took a distance from the beginning of the runway to the point of liftoff was 0.7, what is that, miles? And then Sam also said the velocity at liftoff is 160 miles an hour. And I think that's all we're given. We're looking for the plane's acceleration. So talk to me. I can treat that K just like it was a constant. I can anti-differentiate it. The velocity function would be the antiderivative of whatever that constant is with respect to t. And what would that be? plus some initial velocity, but since we know the initial velocity is 0, I'm just gonna save us a step and not write down the equal 0. The velocity, let's see. I know that the velocity at liftoff is 160, so at some point, that constant times t is going to be 160. Again, I can't find exactly what time the plane lifts off, but I can solve that equation for t in terms of whatever that constant acceleration is. The time at liftoff is going to be 160 divided by k. I just don't know what that k is yet. That's what I'm trying to find. And so I can find the position at liftoff. If I find the position function, and it's the antiderivative of the velocity function. And what's the antiderivative of the velocity function? 1/2, that constant I don't know, times t squared, plus some constant on that end, but what do we know the initial height to be? Plus 0, so I don't have to write plus 0 on the end. So I only lack one thing. I'm trying to find the position at liftoff. I know the time of liftoff. So now what can I do? Beautiful. The position is 0.7 when t is 160 over k squared. So 0.7, I'm going to go ahead and multiply both sides by 2 to clear out the fractions. 1.4 equals 160 squared over, I'd have a k in the denominator because that would be k over k squared. And so that constant would be 160 squared over 1.4. I've already punched that and gotten it to be 18,285.714. What is that? What have we found? That's the acceleration in what units? Actually, the speed was given to us in miles per hour squared, or the speed was given to us in miles per hour, so the acceleration is miles per hour squared. And I'm pretty sure that that's not what the control tower really wants, but to change that to feet per second squared took me just a minute, but I got it to be 7.45 feet per second squared. All right, 54 and 68 were the two hardest in my opinion. The homework, if you've already done day 1, then all you have to do is day 2, and I'll take all of it up together tomorrow.
Absolutely.